Hello there, and welcome to the Sleepy Nature Channel. Tonight, we are going to travel somewhere you might not expect. Somewhere that looks nothing like what you imagine when you close your eyes and picture the word desert. There are no sand dunes here, no blazing sun, no camels walking slowly across an orange horizon. Instead, picture this: silence so complete that you can hear your own heartbeat. A plain of white stretching so far that the sky and the ground seem to become one single breath. A place where the wind moves like a long, slow exhale, cold, clean, impossibly gentle. Antarctica, the southernmost place on Earth, holds a secret that most people never think about. It is, in fact, the largest desert on the planet, not the Sahara, not the Arabian sands. Antarctica. And tonight, you're going to drift into that silence with us, learning why the driest, most windswept wilderness on Earth is wrapped in so much ice, and why that somehow makes it the most peaceful place imaginable. So come, settle in. Let your shoulders soften. Let your breathing slow. There is nothing here but the quiet hum of the world, and a story that will carry you gently, gently toward sleep. To understand why Antarctica is a desert, the very first thing to do is breathe in the idea of what a desert actually is. Most people picture heat, blazing sand, scorching sun, the shimmer of a mirage on the horizon. But a desert in the natural world is simply any place that receives very little precipitation each year, less than 250 millimeters to be precise. The Sahara gets that, the Arabian Desert gets that. And Antarctica? Antarctica receives, on average, less than 200 millimeters of precipitation a year across most of its surface. The interior, that vast, silent plateau of ice at the very heart of the continent, receives less than 50 millimeters. Some parts get even less than that. By any definition, this is a desert, the driest desert on Earth. You might find it strange, lying here in your warm bed, to imagine that a place covered in so much ice could be dry. But ice, you see, is just old water, water that fell a very long time ago and never left. Antarctica has been collecting its ice for millions of years, layer by quiet layer, and what accumulates over millions of years can look like abundance even when the annual gift is almost nothing at all. The air over Antarctica is extraordinary in its stillness. You can feel it even in imagination, that particular kind of cold that does not bite so much as simply hold you. It is the kind of cold that makes the air feel thin and crystalline, like breathing through glass. And cold air, it turns out, holds very little moisture. The warmer air is, the more water it can carry. Cold air is dry air. So the atmosphere over Antarctica, one of the coldest places on Earth, simply cannot carry much water to begin with. What little moisture exists tends to stay locked in ice. Very little falls fresh each year. There is a kind of peace in that dryness. No storms rolling in heavy with rain, no humid afternoons. Just the clean, spare breath of a continent that has learned to exist on almost nothing, and in doing so has become the most pristine place on Earth. The interior plateau sits more than 2,000 meters above sea level in most places, and near the South Pole it rises higher than 2,800 meters. That height matters. High places are colder places, and cold places hold less moisture in the air. Antarctica's elevation is one of the reasons its interior is so astonishingly dry. It is a desert built on a mountain, or rather, a mountain buried so deep under ice that you might not even notice the mountain at all. Ice has its own kind of weight. The ice sheet covering Antarctica is, in places, more than 4 kilometers thick. That is 4 kilometers of frozen time, pressed gently down. Scientists can drill into that ice and pull up cores, long cylinders of frozen history that hold air bubbles from hundreds of thousands of years ago. Imagine breathing air from a time before humans existed. Each tiny bubble is a little archive, a small library of the ancient atmosphere, preserved perfectly in the dry cold. Snow does fall over Antarctica, even if rarely. When it does, it falls as fine, dry crystals, not the heavy, wet snowflakes of a winter storm, but something more like dust, light as breath. You could hold out your hand and barely feel the weight of it landing. These crystals drift and settle and are pressed over centuries into firn, a halfway stage between snow and ice, granular and soft, and then, over more centuries, into true glacier ice. Every layer represents not just a year, but an entire season's silence. The winds of Antarctica are another part of the desert story. Katabatic winds, they are called, gravity winds, flowing downhill from the high interior plateau toward the coast. The word comes from the Greek meaning going downhill. These winds can reach at extraordinary speeds, sometimes exceeding 300 kilometers an hour on the steepest slopes. They pick up loose snow crystals and carry them horizontally across the ice, filling the air with what looks like a low, ground-hugging mist of white. When this happens, visibility can drop to almost nothing, even on a clear day. It is as if the surface of the continent is breathing out. But most of the time, in the interior, the air is still, perfectly, utterly still. And there is something deeply calming about the thought of that kind of stillness. No traffic, no voices, no rustling leaves, just the continent breathing slowly beneath its blanket of ice. Antarctica has been isolated for a very long time. Around 34 million years ago, the Drake Passage, the stretch of ocean between the southern tip of South America and the Antarctic Peninsula, opened up fully, allowing the Antarctic circumpolar current to flow uninterrupted around the entire continent. This current acts like a wall. It keeps warmer waters away from Antarctica, keeping the continent cold, keeping the air dry, sustaining the desert that has existed there since long before humans walked the earth. If you were to stand on the surface of the Antarctic interior at midwinter, the sun would be entirely absent for months. The sky would be a deep, velvety darkness, interrupted only by stars, so many stars unfiltered by any humidity that the Milky Way would hang above you like a luminous river of ancient light. No moisture in the air means no haze. The stars over Antarctica are perhaps the sharpest, clearest stars on Earth. You could almost reach up and touch them. There are places in Antarctica called the Dry Valleys, the McMurdo Dry Valleys, along the coast of the continent. These valleys are so sheltered from ice flow and so scoured by dry winds that no snow has fallen there in perhaps 2 million years. They are the closest thing on Earth to the surface of Mars, rocky, bare, and very still. Streams of meltwater run through them briefly in summer, fed not by rain, but by the slow warmth of polar sunlight melting exposed glacier faces. Then they dry up again, and the silence returns. In those valleys, certain organisms have found ways to live inside rocks. Crypto-endolithic organisms, algae, bacteria, fungi, live just millimeters beneath the surface of translucent stones, where a faint warmth and filtered light create a tiny, almost invisible pocket of life. They are among the hardiest living things on Earth, surviving in conditions almost nothing else could tolerate. There is something quietly wonderful about that. Even in the driest, coldest desert on Earth, life finds a way to whisper. As you lie here, settling deeper into rest, let yourself imagine the surface of that ice. Flat, white, impossibly wide. A sky above that is either pitch dark or endlessly bright, depending on the season. No trees, no soil, just ice and wind and silence. It is a kind of emptiness that is not sad. It is the emptiness of something complete. A world that has everything it needs, which is very little. There is a lesson in that, perhaps, for those of us who sometimes feel we need so much. Antarctica is cold because it sits at the pole, where the sun's rays strike the earth at the lowest angle, spreading their warmth across the widest possible surface. The same amount of sunlight that warms a small patch of tropical ground must spread itself across a vast Antarctic plain, diluted and gentle. Antarctica receives sunlight, but it gives most of it back, reflected away by the brilliant white surface of the ice. The technical term for this is albedo, the measure of how much light a surface reflects. Fresh snow has one of the highest albedos on Earth. It gives almost everything back. Let your eyes grow heavy now. Feel the weight of this quiet desert settling around you, like a snowfall so fine you cannot even feel it land. You are warm. You are safe. The vast white continent drifts at the bottom of the world, holding its ancient ice, breathing its dry, cold air. And you are here, soft and still, drifting toward sleep. The ice of Antarctica does not just sit still, it moves. Slowly, imperceptibly slowly, the way time moves when you're almost asleep, but it moves. Glaciers are rivers of ice, and like rivers, they flow toward the sea. In Antarctica, this flow is driven by the sheer weight of ice pressing down from above. The lower layers of the ice sheet are compressed, and where the pressure and geothermal heat from beneath are just right, they become slightly liquid at the very base. A film of water so thin it is barely real, but thin enough to allow the whole enormous weight of ice above to slide, millimeter by millimeter, outward and downward, toward the coast. This is one of the most peaceful motions in all of nature. You would never see it happen. You would never feel it. But if you could watch a time-lapse of Antarctica over 10,000 years. You would see the ice breathing, flowing outward like a slow exhalation, calving icebergs at the coast, releasing them to drift away north into warmer waters where they slowly melt and return their water to the sea. Every glacier has a personality, scientists sometimes say. Some flow faster than others. Some have streams of fast-moving ice within them, called ice streams, that carry material to the coast several times faster than the surrounding ice. The Thwaites Glacier is one such place, broad and slow and ancient. It drains a vast portion of the West Antarctic ice sheet, funneling ice toward the Amundsen Sea. When icebergs calve from its front, they are not small. Some are the size of cities. An iceberg calved from Antarctica can drift for years. It travels north through the Southern Ocean, slowly melting, occasionally running aground on underwater ridges, turning and tumbling in the current. As it melts, it releases the ancient, filtered fresh water it has been holding for thousands of years into the sea around it. Tiny ecosystems form in its shadow. Phytoplankton bloom in the nutrients released from the melting ice. And where phytoplankton bloom, krill gather, and where krill gather, life follows. Even in death, an Antarctic iceberg gives something back. The color of Antarctic ice is not always white. Deep inside a glacier, the ice takes on a quality of blue, sometimes a pale, icy blue, like the inside of a pearl, and sometimes a deep, rich blue, like the sky at dusk. This is because ice absorbs red wavelengths of light more readily than blue. When light filters through enough ice, the red is swallowed up, and only the blue remains. Old glacial ice, dense and bubble-free, glows from within with a color so pure it seems almost impossible. If you were to stand inside an ice cave in Antarctica, surrounded by that blue light, you might feel as though you were underwater or inside a dream. Ice caves form where meltwater flows beneath the surface, where geothermal heat from volcanic activity or the friction of flowing ice melts tunnels through the glacier from below. Ross Island, home to the U.S. McMurdo Station, sits near Mount Erebus, one of only a handful of permanently active volcanoes on Earth, and the southernmost active volcano in existence. The heat from Erebus creates ice caves on its slopes, some of which are warm enough to support small ecosystems of mosses and microbes. Steam vents through the ice, melting chambers and corridors that catch the light in shades of gold and blue and soft, milky white. If you enjoy the channel and find these stories restful, please do leave a like. It helps more people find their way here, and every small note of kindness is deeply appreciated. The surface of Antarctica during summer is not entirely static. When the sun sits low on the horizon and light rakes across the ice at a shallow angle, the surface becomes extraordinarily beautiful. Every irregularity is thrown into relief. Sastrugi, those ridged, wind-carved forms of hard snow, cast long violet shadows. Sastrugi can be as small as a ripple in sand, or as large as a wave, frozen mid-curl, waist-high and hard as concrete. Walking across a sastrugi field is to walk across the written record of every wind that has ever blown in that direction, each gust preserved in hard, bright white. Antarctica's snow does not pack the way temperate snow does. It is too dry, too cold, too fine. It does not make good snowballs. It flows like dry sand, piling in drifts behind any obstacle. Some expeditions have returned to their parked vehicles after only a few days to find them half buried in wind-driven snow, as if the desert were gently trying to reclaim them. Beneath the ice, Antarctica holds mountains, valleys, lakes, and rivers that almost no one knows about. The Gamburtsev subglacial mountains are an entire mountain range buried beneath the East Antarctic ice sheet, their peaks buried under ice more than a kilometer deep. They were discovered by Soviet scientists in the 1950s using seismic surveys. No human eye has ever seen them directly. They exist in total darkness, pressed beneath the weight of countless millennia of ice, as perfectly preserved and as unknown as dreams. Lake Vostok is perhaps the most extraordinary of all. It is a subglacial lake, a body of liquid water sealed beneath nearly 4 kilometers of ice. It has been isolated from the surface and from the rest of the world's water for somewhere between 15 and 35 million years. It is roughly the size of Lake Ontario. Whatever life exists in its cold, dark water has had millions of years to evolve in complete isolation, sustained by geothermal heat and the chemical energy of dissolved minerals rather than sunlight. Scientists have drilled to within a few hundred meters of Lake Vostok, and the anticipation of what might be found there is immense. The lake waits, patient and silent, holding its secrets beneath the weight of the ice above. There are dozens of such lakes beneath the Antarctic ice sheet. Some are connected by subglacial rivers, rivers that flow in pitch darkness kilometers underground beneath millions of tons of ice. The idea of it is strangely comforting. Rivers flowing quietly, unseen, in the most remote place on earth. Water finding its way, as it always does. As you breathe slowly here, let the weight of this ancient world settle around you. Kilometers of ice above, rivers in the dark below, the blue glow of glacial caves, the wind-carved sastrugi, the stars impossibly sharp, overhead. There is a stillness in all of this that belongs to you, too, the stillness of something very old and very patient, resting in the cold. The air over Antarctica is the cleanest air on Earth. There is essentially nothing in it that should not be there. No exhaust, no smoke, no pollen. Pollen requires plants, and plants require soil, and Antarctica has almost none. What little soil exists is on the exposed rock outcrops and the dry valleys, and it is thin and cold and ancient. The air above is a perfect, unspoiled transparency, so clear that atmospheric scientists travel to Antarctica specifically to study the rest of the atmosphere from there, because nothing locally interferes with the measurements. When you breathe deeply tonight, imagine that air, cold and clean and old, every cubic centimeter of it the same as it was 1,000,000 years ago, or nearly. There is a comfort in that kind of purity. The ozone layer above Antarctica became famous in the latter part of the 20th century, when scientists discovered a seasonal thinning, a hole that forms each spring over the continent. This happens because of a particular kind of chemistry that occurs in the very cold, very still air of the polar stratosphere. When temperatures drop low enough, polar stratospheric clouds form at high altitudes. These clouds, made of ice crystals and nitric acid, provide surfaces on which chemical reactions can take place, reactions that release chlorine atoms from human-made compounds, and those free chlorine atoms then break down ozone molecules. One chlorine atom can destroy thousands of ozone molecules in a chain reaction. The good news, and there is genuinely good news here, is that since the Montreal Protocol of 1987, which phased out many of the chemicals responsible, the ozone hole has been slowly, measurably recovering. This is one of the most remarkable environmental success stories in human history. A global problem identified, a global response mounted, and the damage, very slowly, beginning to heal. The stratosphere is patient. It will wait for us. Light behaves strangely over Antarctica. Because the air is so dry and clean, there is almost no haze. Distances are extraordinarily difficult to judge. A mountain that looks like a day's walk away might take a week to reach. Early Antarctic explorers were frequently deceived by this optical clarity. The desert air offers no lies, only a perfect, merciless transparency. During the austral summer, the sun does not set for weeks. It circles the horizon at a low angle, casting golden light that never fully darkens. Shadows are long and permanent seeming, stretching across the ice in colors that shift from gold to pink to a deep, luminous violet as hours pass. Ice crystals in the air catch this angled light and scatter it, sometimes creating sundogs, those bright, rainbow-tinted spots that appear on either side of the sun like companionable ghosts walking alongside it in the sky. Halos form around the sun in the cold polar air, great rings of diffracted light. Pillars of light extend upward and downward from the sun through scattered ice crystals. Diamond dust, a precipitation of tiny ice crystals so small they are barely visible, falls in the still air, each crystal a tiny prism, and the air seems to glitter. These are not rare events over Antarctica. They happen quietly and regularly, witnessed by almost no one, as if the sky were putting on a private performance for the ice. Sunsets over Antarctica, when they happen at all in the transitional months, are extraordinary. The sun can linger on the horizon for hours, changing color so slowly that each shift is almost imperceptible, until suddenly the sky is a different kind of rose, a different kind of amber than it was before. The colors are unusually pure because the air is so clean, no particles to scatter extra light. Just the sun, the ice, and the sky, talking quietly to each other in shades of color most of us never see. At the other extreme, polar winter brings months of total darkness. The sun disappears entirely, and the only light comes from the moon, the stars, and the aurora australis, the southern lights. If you have ever seen the aurora borealis in the north, you already have some sense of what this is. But the aurora australis over Antarctica can be overwhelming in scale and complexity. Without any light pollution for hundreds of kilometers in every direction, the curtains of light fill the entire sky, green, pink, violet, white, rippling and swelling and fading like something breathing. The aurora is caused by charged particles from the sun colliding with oxygen and nitrogen atoms in the upper atmosphere. The oxygen atoms, excited by the collision, release that energy as light. The particular green of polar auroras is the wavelength released by oxygen at around 100 kilometers altitude. At higher altitudes, oxygen releases a rarer red. Nitrogen contributes blue and purple. It is, in the most literal sense, the atmosphere singing. The silence of Antarctic nights during winter is a particular kind of silence that people who have experienced it describe with difficulty. It is not just the absence of sound. It is the presence of quiet, a positive, almost physical quality, like something you could cup in your hands. Winter over personnel at research stations, the small groups of scientists and support staff who remain through the months of darkness, speak of the silence as one of the most powerful experiences of their lives. In the long winter dark, with temperatures dropping to -60 or lower, and the stars wheeling overhead in their endless circle, Antarctica becomes a place entirely outside ordinary experience. It is easy to understand why the far south has always stirred the imagination, a place at the edge of the world where ordinary rules seem not to apply, where time moves differently, where the sky does things it does nowhere else. But Antarctica is not mythological. It is real. And it is resting right now at the bottom of the world in its dry, cold silence, the same as it has been for millions of years. Let that thought settle over you like the finest, driest snow. Barely a weight at all, just a softness, a quiet, a sense of something very large and very still holding you gently in the dark. Antarctica has not always been a desert. Long ago, tens of millions of years ago, it was warm. It sat further north, connected to other landmasses, and it was covered in forests. Not sparse boreal forests, but lush subtropical forests, filled with ferns and cycads and trees we would recognize, as well as many we would not. Dinosaurs walked there, not in the ice, but on green ground, beneath a sky, with a sun that set every evening and rose every morning, as suns should. The evidence for this is written in the rocks. In the Transantarctic Mountains, a chain of peaks that crosses the continent from coast to coast, geologists have found fossil wood. Not impressions or traces, but actual preserved wood, the cell structure still visible under a microscope, from trees that grew in warm Antarctic forests more than 250 million years ago. They have found leaf fossils, fern fossils, the bones of dinosaurs. Antarctica holds a fossil record of its former lives, buried under the ice, waiting to be read. During the Cretaceous period around 100 million years ago, the poles were warm enough that there was no polar ice at all. Sea levels were much higher, and the planet was blanketed by forests from equator to pole. Antarctica had months of polar night, as it does now, but in the summer the sun circled continuously, and under that endless light ancient forests grew. The trees that survived those months of darkness may have lost their leaves and entered a form of dormancy, the way deciduous trees do today, but come the light, they grew vigorously. All of that warmth is gone now. The isolation of Antarctica by the circumpolar current and the gradual cooling of the global climate turned the continent slowly into the desert it is today. The change was not sudden. It took millions of years. The forests thinned, the temperatures dropped, the ice crept in from the highest elevations first and then spread outward. The trees gave way to tundra, the tundra to bare rock, the bare rock to ice. Layer by layer, year by year, the desert grew. What lives in Antarctica today is almost unimaginably different from those ancient forests. And yet, something does live there. In the soil of the dry valleys and the exposed rock outcrops, a handful of plants have found a way. 2 species of flowering plant live on the Antarctic Peninsula and its nearby islands, the Antarctic hairgrass and the Antarctic pearlwort. They are small, hardy, green against the rock, forming low cushions that catch warmth from the sun-heated stone beneath. They are among the southernmost plants on Earth. These plants are patient. They grow very slowly, accumulating resources across the short, intense summer and surviving the long, dark winter in a state of suspended stillness. Some individual cushions of pearlwort may be very old, decades or more of incremental growth, ring by ring, year by year, a life lived at the pace of ice. There is something deeply peaceful about a plant that has learned to want very little, to need very little, to simply be. Mosses and liverworts are more widespread in the milder, ice-free coastal areas. Some species of Antarctic moss have been found alive after being frozen in permafrost for more than 1,500 years. Scientists thawed them gently, provided them with light and water, and they grew again. Life, very old and very patient, resuming where it left off. Lichens are perhaps the most successful visible organisms in Antarctica. Lichens are not single organisms, but partnerships, a fungus and a photosynthetic partner living in such intimate union that neither could survive without the other. In Antarctica, lichens colonize bare rock, growing so slowly that some patches may be thousands of years old. They contribute to the weathering of rock, producing tiny amounts of organic material, the first step toward a soil that could, in theory, support more complex life. They are pioneers, infinitely patient. The colors of Antarctic lichens are extraordinary. Against the dark volcanic rock, they paint the landscape in patches of orange, lemon yellow, gray-green, and rust. These colors are not decorative. They are adaptations. Dark pigments absorb more solar radiation, warming the lichen in an environment where warmth is rare. Each patch is a small, careful negotiation with the environment, a conversation between living things and the cold. There is a particular pleasure in knowing that even here, In the most spare and empty-seeming desert on earth, color persists. That something chooses orange on a gray rock, yellow in all that white. That life, even at its most stripped down, finds a way to be beautiful. As you lie here, let yourself imagine those small orange and yellow patches on dark Antarctic rock. The wind moving over them, barely disturbing a single tiny lobe. The sun warming them from one angle, then another. The ice in the distance, vast and white. And here in the foreground, a small, bright, ancient thing quietly living. That is Antarctica, too. Not only the emptiness, but the small, careful, colorful life that persists within it. The deeper you go into sleep, the more the world simplifies. The details soften, the outlines blur, and what remains is sensation, warmth, quiet, the particular comfort of not needing to move or decide or do anything at all. Antarctica, in its own way, knows that feeling. It has been resting in its desert silence for millions of years, and it will rest for millions more. Let its patience be yours tonight. The southern ocean that surrounds Antarctica is not calm. It is one of the most dynamic, powerful bodies of water on Earth. Waves can reach heights of 15 meters or more, driven by the Antarctic circumpolar current, the only ocean current that flows uninterrupted all the way around the globe, with no landmass to stop it. This current carries more water than all the world's rivers combined. It is a river of ocean, immense and perpetual, circling the bottom of the world. But from Antarctica itself, the Southern Ocean can look different. On a still day, and there are still days even here, the ocean spreads out like gray glass, and the icebergs that calved from glaciers weeks or months ago drift slowly, reflecting the low sun in their blue-white faces. Some of them are tabular, flat-topped with vertical sides, like tables or buildings or islands, and some are older, more rounded, sculpted by waves, and melt into abstract shapes that catch the eye. The bergs drift north along predictable paths, guided by wind and current. As they enter warmer latitudes, they melt at their water lines, leaving overhangs of ice above the sea surface. Sometimes these overhangs collapse, sending up a brief white spray, and the berg rolls slightly in the water, like something turning over in sleep. As they get smaller, they become more rounded, their blue caves emerging at the waterline. Eventually they are small enough that waves move through them and over them. And then they are just cold, fresh water rejoining the sea. Beneath the surface, the Southern Ocean is rich beyond imagination. Antarctic krill, small shrimp-like crustaceans barely a few centimeters long, form the foundation of almost the entire Southern Ocean food web. They exist in swarms so vast that they can be detected by satellite. They eat phytoplankton, the microscopic plant-like organisms that bloom in the sunlit surface, waters each spring, and they are in turn eaten by nearly everything else: penguins, seals, whales, albatrosses, petrels. Krill are, in some estimations, among the most numerous animals on Earth by mass. Phytoplankton themselves are extraordinary things. Each one is a single cell, so small that millions can fit in a drop of water, and yet together they perform roughly half of all photosynthesis on Earth. They take up carbon dioxide from the ocean, use the sun's energy to combine it with water and nutrients, and produce oxygen as a byproduct. Every second breath you take was produced at some point by phytoplankton in the ocean. Antarctica's waters are especially fertile in spring, when melting sea ice releases nutrients that have been trapped since the previous summer, triggering blooms of incredible density. If you leave a like on this video, it helps more sleepy wanderers find their way here, and that, to us, feels like a small gift worth giving. The Antarctic toothfish has a remarkable form of antifreeze in its blood, proteins that bind to ice crystals as they form and prevent them from growing, keeping the fish's blood from freezing solid even at temperatures several degrees below zero. This biological antifreeze is a remarkable piece of molecular engineering, evolved over millions of years in the cold polar water. The same kinds of proteins that make up so many living things, just arranged in a way that makes them uniquely effective at holding ice at bay. Weddell seals are perhaps the most serene of all Antarctic animals. They spend most of their time beneath the sea ice, surfacing through breathing holes they keep open by gnawing the ice with their teeth. They can dive to depths of over 600 meters and hold their breath for over 80 minutes. Beneath the ice, in the cold, dim light, they hunt fish and squid with a calm efficiency, and then they surface, haul themselves out onto the ice, and sleep. They sleep a great deal, these seals. They sprawl on the ice with an expression of complete contentment, their round bodies rising and falling, their whiskers occasionally twitching. Emperor penguins are the largest of all penguin species, and they make their home in Antarctica year-round, the only bird species that breeds in Antarctic winter. They huddle in their thousands on the ice, sharing warmth, rotating slowly through the group so that each bird spends time in the warmer interior and time on the colder exterior, an instinctive, collective generosity. In the center of the huddle, the temperature can be as much as 20 degrees warmer than outside, a precious pool of shared warmth in the cold. The male emperor penguin stands and holds an egg on his feet, tucked beneath a fold of warm skin through the entire Antarctic winter. For 2 months he does not eat, does not move far, only shuffles and huddles. He loses almost half his body weight. When the egg hatches, he feeds the new chick on a secretion from his own crop until the female returns from the sea. This patience, this endurance, this quiet dedication, performed in the darkest, coldest place on earth, is one of the most extraordinary things in the natural world. Let the warmth of the penguin huddle settle over you. Thousands of warm, round bodies pressed together in the dark and cold, each one holding the others up. The soft, low calls that penguins use to recognize each other in the crowd. The ice gleaming faintly in the winter dark. The sky above, full of stars, and the rippling green of the aurora. And in the middle of all that cold, all that dark, all that desert, warmth, life, the patient, unshakable persistence of warmth. The albatross, to those who have sailed the Southern Ocean, is something close to a symbol of the sea itself. The wandering albatross has the longest wingspan of any living bird, up to 3.5 meters from tip to tip, and it uses that wingspan to travel almost without effort, riding the winds that circle Antarctica, barely needing to flap. It soars. It glides in long curving arcs, dipping close to the wave tops, and then rising again, using the gradient of wind speed from near the water's surface to higher air to generate lift without expenditure. This technique is called dynamic soaring, and the albatross has perfected it over millions of years of evolution. An albatross can circle the globe in 46 days. It travels thousands of kilometers from its breeding colony on South Georgia Island or the Crozet Islands to feed in Antarctic waters, then returns. It may cover 1,000 kilometers in a single day, barely moving a muscle. In the air, the albatross is effortless. It is one of the most extraordinary flyers on Earth, and watching one is like watching something that belongs entirely to the wind. South Georgia Island in the South Atlantic is one of the great wildlife sanctuaries of the world. It is a rugged, mountainous island surrounded by glaciers, far south and far from anything, and it hosts breeding colonies of albatrosses and penguins of staggering size. Hundreds of thousands of king penguins breed there, their orange and black bodies covering the beaches from end to end. And yet, for all the noise, there is also peace, the rhythm of a colony doing what it has always done, living in the way that it lives, in a place almost no human ever sees. The Southern Ocean is full of petrels, small, medium, and large seabirds that belong to the same order as the albatross. Snow petrels are perhaps the most beautiful of all, pure white, with small black eyes and beaks. They look like they were made from the ice itself, like small pieces of Antarctica given wings. They breed on inland rocky outcrops, sometimes 300 kilometers from the coast, and they fly out to sea to feed, returning across the ice landscape with their white wings glowing in the low polar light. Cape petrels have striking black and white patterned wings, like watercolor splashes of dark ink on white. They follow ships across the Southern Ocean, riding the ship's wind shadow, swirling and tilting, always just above the waves. They eat krill, squid, small fish, whatever the sea offers up. They are joyful birds, if a bird can be said to be joyful. They seem to find the wind endlessly entertaining. The sea ice itself, the ice that forms each winter on the surface of the Southern Ocean and retreats each summer, is a habitat. Beneath the ice, in a thin interface zone between ice and water, communities of algae grow in remarkable densities. These ice algae are the first food available to krill in spring, before the open water phytoplankton bloom begins. They are brownish and orange, and in places where the ice is thin enough, their presence turns the underside of the ice the color of old wood. Looking up from below, through the ice, the sky above would appear as a continuous pale glow, filtered and softened, interrupted by this living layer of gold. Ice algae have adapted to live in conditions of intense cold, high salinity, and fluctuating light. They produce antifreeze compounds of their own. They photosynthesize at temperatures that would damage or kill most other photosynthesizing organisms. They are some of the most resilient primary producers on Earth, the quiet base of a food web that supports everything from krill to the great whales. Humpback whales make their way to Antarctic waters each summer to feed. After spending the winter in tropical breeding grounds off the coasts of Colombia, Hawaii, and Tonga, they swim thousands of kilometers south to reach the krill-rich waters of the Southern Ocean. Here, they feed intensively, accumulating the energy reserves they will need to survive the winter and reproduce. The entire southern summer is a festival of eating, a quiet, enormous communion with the sea. Humpbacks feed using bubble nets, a technique in which they dive below a school of krill or small fish and blow a spiral of bubbles as they swim upward in a circle. The bubbles form a curtain that confuses and concentrates the prey, and then the whale lunges upward through the middle, mouth open, engulfing enormous quantities of krill-rich water in a single gulp. It is a slow, elaborate, beautiful technique, used in concert with other whales who coordinate their dives and surfacings. The breathing of a whale is an extraordinarily peaceful sound, a slow, deep exhalation, the blow, the plume of warm vapor rising in the cold air, and then the long inhalation, and then silence as the whale dives again. There is something almost meditative about it, something that slows your own breathing just to witness, even in imagination. Let your breathing slow now like a whale's, deep and slow and full, each breath a small, complete moment. The Southern Ocean moving around you, gray and vast and alive. The albatross overhead tilting into the wind, the snow petrel's white wings against the ice, the cold, clean air. And beneath it all, the desert, the great white desert, resting in its ancient quiet. Deep in the heart of the East Antarctic ice sheet, at the point farthest from any ocean coast, sits the South Pole of inaccessibility, the most remote point on the continent, the place on Earth that is farthest from the sea in all directions. To reach it, you would travel hundreds of kilometers across featureless ice plateau at an elevation of nearly 4,000 meters, in air so thin and so cold that breathing is a labor. No animal lives here permanently, no plant, almost nothing. The wind moves over this place with a slow, erasing patience, and the ice beneath is ancient beyond ordinary reckoning. The geographic South Pole is different, slightly more accessible in the relative sense. A U.S. research station sits there, the Amundsen Scott South Pole Station, maintained year-round. The station must be regularly elevated on its stilts because the ice it sits on slowly accumulates new snowfall, and without lifting, the building would eventually be buried. The ice beneath the station is moving too. The entire ice sheet flows at a few meters per year, carrying everything on it northward. The physical South Pole marker must be moved each year to compensate for this drift. Standing at the South Pole, the actual geographic point where the Earth's rotation axis meets the surface, you stand in a place where every direction is north. There is no east. There is no west. Every compass bearing from that spot leads away from the pole, outward, northward, toward the rest of the world. There is something wonderfully simple about that. All complexity stripped away. A single point from which everything radiates. The South Pole sits at an altitude of about 2,835 meters above sea level. The altitude makes the cold even more biting. At such elevation, the atmosphere is thinner, and the sun's rays, when they exist, heat less efficiently. Winter temperatures routinely drop below minus 60 degrees Celsius, and yet people live there, through the winter, in the dark. A small group of scientists and support staff, the Winter Over crew, who choose to remain through the months of polar night. They describe it in ways that are strangely similar to descriptions of deep meditation. The enforced simplicity, the clarity that comes from isolation, the way the mind, deprived of its usual distractions, turns inward and becomes, in its own way, very quiet. Please remember to check the playlist if you would like more of these stories. It is a gentle collection, ready for whenever you need to rest. Night at the South Pole is not like night anywhere else. When the sun sets, which it does once a year in March, it does so slowly, tracing a low spiral down to the horizon over the course of days rather than hours. And then it is gone, and the darkness that descends is complete. But the stars are always there, unwavering in the dry, still air. The same stars, night after night, circling overhead in a slow, stately rotation around the celestial South Pole, around which everything slowly turns. The aurora australis appears frequently at the South Pole in winter, painting the sky in its shifting colors. At the pole, the aurora has a different character than it does at lower latitudes. The magnetic field lines converge there, and the auroral oval is all around you. Sometimes the aurora forms a complete ring overhead, a crown of light, and if you stand at the exact pole and look straight up, you see the aurora wrapping above you in all directions simultaneously. It is like standing inside a lantern. The coldest naturally recorded temperature in Earth's history was measured in Antarctica, in the East Antarctic Plateau, at approximately minus 98 degrees Celsius. That is 98 degrees below the freezing point of water. A temperature so extreme that almost nothing familiar to everyday life can exist in it. But here is what is also true, that extreme cold is making something beautiful. When temperatures drop very low, diamond dust fills the air, those tiny suspended ice crystals that fall continuously, each one catching light and scattering it in tiny rainbows. In the beam of a headlamp or a flashlight, diamond dust turns the air into a galaxy of sparkling motes. Standing in diamond dust is like standing inside a snow globe, the flakes so fine they barely move, hanging suspended, drifting imperceptibly, turning the darkness into something luminous. There is a lesson hidden somewhere in all of this. If something as extraordinary as diamond dust and aurora can happen in -98-degree air, then perhaps beauty is not a function of comfort or ease, but of something more fundamental, something that just happens wherever the conditions allow, however unlikely those conditions might seem. Let that thought rest with you. The diamond dust in the polar dark, the aurora overhead, the ice stretching endlessly in every direction, and you, warm in your bed, watching it all from behind the soft curtain of approaching sleep. Antarctica has a story that stretches back further than ice. The continent itself, the land beneath the ice, is ancient rock, some of it among the oldest on Earth. Parts of the East Antarctic Craton, the deep basement of the continent, contain rocks dating back more than 3.8 billion years. That is more than 3/4 of the entire age of the Earth. When those rocks were formed, the planet was unrecognizably different. No oxygen in the atmosphere, no ozone layer, no complex life. Just rock and water and heat. The continents have not always been arranged as they are today. Antarctica once was part of Gondwana, the great southern supercontinent that existed for hundreds of millions of years and included what would become South America, Africa, India, Australia, and Antarctica, all pressed together in a single vast landmass. Gondwana began to break apart around 180 million years ago, its pieces drifting slowly apart as new seafloor formed at spreading ridges. Antarctica moved south. Its fellow fragments moved north and east. India drifted north so rapidly, in geological terms, that it eventually collided with Asia, crumpling the crust upward into the Himalayas. All of this movement was slow, centimeters per year, roughly the rate at which your fingernails grow. But, given enough time, centimeters become thousands of kilometers, and land masses that were once neighbors become oceans apart. The slowness of it is part of what makes it so calming to contemplate. The Earth is patient. It does not rush. The Transantarctic Mountains are one of the longest mountain ranges on Earth, stretching approximately 3,500 kilometers across the continent. They form the boundary between East and West Antarctica, and in places they rise to more than 4,500 meters above sea level. The tallest peak in Antarctica, Vinson Massif, reaches 4,892 meters. Climbers who reach its summit see, in every direction, nothing but white. The vast white desert stretching to every horizon. Geologically, Antarctica is still active in places. Deception Island in the South Shetland Islands is a volcanic caldera open to the sea, its inner harbor accessible through a narrow gap in the rim. The water inside is warm from geothermal activity, warm enough in places that you can bathe in it, though the surrounding air is Antarctic cold. It is one of the most extraordinary natural swimming spots on Earth. The ice sheet interacts with the bedrock beneath it, with the ocean around it, and with the atmosphere above. As the ice flows outward from the continent's interior, it exerts enormous pressure on the bedrock, pushing it slowly down, a process called isostatic depression. In areas where the ice has retreated in the past, the land is slowly rebounding upward, rising at measurable rates as the weight is relieved. Scandinavia is rising at a rate of several millimeters per year for exactly this reason. Beneath the ice of Antarctica, where geothermal heat from the Earth's interior is sufficient, the bedrock is sometimes wet. Geothermal heat, the slow seepage of heat from the planet's interior, generated by the decay of radioactive elements deep within the Earth, melts the base of the ice sheet in some places. This heat is imperceptible at the surface, drowned out by the cold from above. But kilometers down, in the darkness, the Earth is always gently warm. There is something comforting about that. The planet's own warmth, working slowly and quietly beneath the ice. The same heat that drives volcanoes and creates hot springs and warms the ocean floor where hydrothermal vents pour out mineral-rich water. The same fundamental warmth is also there, beneath Antarctica, in the quiet dark. The Earth holds its heat. It keeps it deep inside and shares it slowly at the deepest places where ice meets rock. Coal has been found in Antarctica. Coal formed from the compressed remains of those ancient forests that grew there hundreds of millions of years ago. Its existence is a reminder of the warmth that Antarctica once knew, of the ferns and cycads and trees that once covered this continent, of a time when the desert was a forest and the forest was warm. Fossils of the freshwater reptile Lystrosaurus have been found in Antarctica, matching fossils found in Africa and India. This is some of the most powerful evidence for the theory of continental drift, that these continents were once connected. Lystrosaurus could not swim across an ocean. The fact that it exists on multiple continents proves that those continents were once one. A small, squat, rather endearing mammal-like reptile that lived about 250 million years ago, connecting continents across the depths of time. Antarctica also holds fossils of Glossopteris, a fern-like plant that grew on Gondwana. The discovery of Glossopteris fossils in Antarctica by early Antarctic explorers, including Scott's ill-fated last expedition, was a significant scientific finding brought back at great cost. The fossils were carried in the sledge loads right to the end of the doomed journey, evidence of the natural world, even as the world turned hostile. Let that quiet dedication rest gently in your thoughts as you drift toward sleep. The ice does not just hold history. It is also a present and active part of the Earth's climate system. Antarctica influences the entire planet in ways that operate over timescales much longer than any human life, but that are nonetheless real and ongoing. The deep water that forms around Antarctica, cold, dense, and sinking, drives the global ocean circulation system. This system, called the thermohaline circulation, moves heat and nutrients around the entire ocean, influencing climates from the tropics to the Arctic. Here is how it works, in simple terms. Around Antarctica, surface water is very cold and very salty. Cold water is denser than warm water, and salty water is denser than fresh water. So this cold, salty Antarctic water sinks. It descends to the seafloor and flows northward along the ocean bottom. This motion drives water upward in other parts of the ocean, creating the great conveyor belt of ocean circulation. The warm surface currents of the Atlantic, including the Gulf Stream, are in part driven by this Antarctic bottom water formation. Without the cold, deep water forming around Antarctica, the climates of Western Europe would change significantly. Antarctica, then, is not just a desert at the bottom of the world. It is a pump, a driver, a thermostat. It helps regulate the temperature of the entire planet. Its cold and its weight and its presence in the far south are part of the reason the rest of the world's climate is as it is. The largest desert on Earth is also one of the most important pieces of the global system. Sea ice, which forms around Antarctica each winter and retreats each summer, plays a role as well. It reflects sunlight, its high albedo bouncing solar energy back into space, cooling the planet. In winter, sea ice covers an area roughly equal to the continent itself, nearly doubling the white, reflective surface of Antarctica. The annual expansion and contraction of Antarctic sea ice is one of the largest seasonal changes in the Earth's surface, happening each year as reliably as the turning of the seasons. Beneath the sea ice, in winter, as ice forms, it excludes salt, and the brine drains downward in thin, concentrated tendrils called brinicles. Brinicles, sometimes called ice stalactites, grow downward from the underside of forming sea ice, descending toward the sea floor. They are surrounded by a sheath of ice. As the supercooled brine contacts the slightly warmer seawater around it, that water freezes too, forming a tube of ice around the descending brine. It is an extraordinary image. That slow, quiet, cold finger of ice reaching downward through the dark water. Not harmful, just a process. Nature doing what nature does in the dark, where almost no one ever sees. The sea floor around Antarctica is in many places extraordinarily rich. The cold, oxygen-rich water supports dense communities of organisms that grow slowly but luxuriantly. Sea spiders grow to enormous sizes in Antarctic water, a phenomenon called polar gigantism that also affects sea urchins, isopods, and other invertebrates. The cold slows their metabolism, allowing them to grow for longer before reaching reproductive age. Antarctic sponges are among the slowest growing organisms on Earth. Some species grow just a millimeter or two per year, and some Antarctic sponges may be more than 1,500 years old. Contemporaries in a sense of medieval cathedrals, growing on the seafloor in absolute cold and darkness, since long before any living person's oldest ancestor was born. They filter seawater through their porous bodies, extracting bacteria and other tiny particles of food, doing nothing else, in the cold and the dark, for centuries. There is a deep peace in the idea of that kind of patience. Not urgency, not haste, just the slow, continuous work of being alive. The sponge does not know it is old. It does not plan ahead. It simply is, day after day, century after century, in the cold, dark water. And that quiet persistence is, in its way, a kind of wisdom. And if this journey has brought you any peace tonight, please do leave a comment, even just a word or two. Knowing you were here, that these stories found their way to you, means a great deal. There are forms of life at the bottom of the ocean around Antarctica that no human eye has ever seen. Creatures in the deep dark, living on the slow rain of organic particles that sinks from the surface ocean, what scientists call marine snow, a continuous, gentle fall of tiny particles that accumulates on the seafloor as the most gradual possible sediment. Over millions of years, this marine snow has built up into the sediments that hold the geological record of the ocean's past. Core them, and you can read the history of the ocean, layer by layer, going back millions of years. Rest now. Let the images settle. The sea spiders in the cold dark, the ancient sponges on their rocky perches, the marine snow drifting down particle by particle so slowly, the ocean floor of Antarctica, unseen, unknown, teeming with quiet life. And above it all, the ice, and above the ice, the sky, and above the sky, the stars. All of it resting in the enormous, peaceful dark. The relationship between Antarctica and the rest of Earth is written most clearly in ice cores. These cylinders of ice, drilled from the ice sheet at places like Dome Sea in East Antarctica, contain within them a detailed archive of the past 800,000 years, 8 full cycles of glacial advance and retreat, recorded in the chemistry of the ice and the tiny bubbles of ancient air trapped within it. By analyzing the oxygen isotopes in the ice, scientists can determine the temperature of the atmosphere at the time the snow fell. By analyzing the air in the bubbles, they can measure the concentrations of greenhouse gases, carbon dioxide, methane, at any given point in the past. The record shows a rhythmic pattern, approximately every 100,000 years. The climate cycles between cold glacial periods and warmer interglacial periods. The last glacial maximum, when ice sheets covered much of Europe and North America, was about 20,000 years ago. The warm interglacial period we now live in began around 12,000 years ago. During the cold periods, carbon dioxide levels in the atmosphere were around 180 parts per million. During warm periods, they were around 280. The correlation between CO2 and temperature in the ice core record is one of the clearest relationships in all of paleoclimatology. The ice core record extends back about 800,000 years, but a project called Beyond Epoca is working to drill an ice core that would extend the record back 1.5 million years. This would allow scientists to study a period before the 100,000-year glacial cycles dominated, when glacial cycles were shorter, about 41,000 years. The oldest air ever recovered from the ice is already extraordinary. Air from 800,000 years ago, before any modern human existed. Air from a time when the world was unimaginably different. And here is the thing about that air. It is just air. The same nitrogen, the same oxygen, the same basic composition. The concentrations of greenhouse gases are different, and that makes an enormous difference. But at its core, the ancient air is recognizable. The same sky, the same breath, the same planet, just wearing a different set of seasons. There are times during the year when extraordinary optical effects appear over Antarctica. Temperature inversions cause light to bend, and this bending can lift the image of the sun slightly above the actual horizon, allowing it to be seen for minutes or even hours longer than geometry alone would predict. Sometimes the sun appears elongated, flattened, distorted into a shape that is almost square, or divided into multiple mirrored segments stacked on top of each other. A sun that looks like a dream of a sun rather than the sun itself. The green flash, a brief moment of green light that appears at the very top of the sun as it sets, is more commonly seen in Antarctica than almost anywhere else, because the flat horizon and clean air allow the sun to set so slowly and so clearly. The green flash lasts only a second or two at normal latitudes, but in Antarctica, some observers report a sustained green flash lasting minutes, a prolonged emerald gleam on the horizon as the sun makes its long, slow exit. It is one of the most beautiful things in the natural world. What is it about the Antarctic night sky that so many people who have seen it describe as life-changing? Perhaps it is the sheer clarity, nothing between you and the stars. Perhaps it is the scale. The sky seems larger there, or the viewer smaller, or both. Perhaps it is the isolation, knowing that in every direction for hundreds or thousands of kilometers there is only ice and ocean and dark, and you are here, small, warm, breathing. Perhaps it is the combination of all of this into an experience so unlike ordinary life that the mind lets go of everything it normally holds. Let your mind let go tonight. Nothing holds you here but the warmth of your bed and the softness of your breath. Everything else can rest. The stars are there whether you watch them or not. The aurora moves without your attendance. The ice breathes. The ocean turns. The ancient sponges grow their millimeter of growth. All of it happening quietly, without asking anything of you. There is a question that scientists have wondered about for a very long time. Could Antarctica be hiding something we have not found yet? The continent is so large, so remote, so covered in ice, that less than 2% of its bedrock has ever been directly examined. The rest lies beneath kilometers of ice, dark and inaccessible. There could be unknown mountains, undiscovered valleys, lakes we do not yet know about. Almost certainly there are. The subglacial map of Antarctica is still being pieced together from radar surveys and seismic data, and each new expedition adds detail to a picture that is still far from complete. There might also be unknown species. The Southern Ocean is among the least surveyed environments on Earth. Expeditions that trawl the deep waters around Antarctica regularly find species new to science: worms, crustaceans, fish, invertebrates of extraordinary variety and strangeness. The deep ocean around Antarctica is not a uniform, barren place. It is a complex, layered environment full of niches and microhabitats, each hosting its own community of organisms that have evolved over millions of years to fill their particular corner of the dark water. The mountains of the Gamburtsev subglacial range, buried entirely under ice, have never been seen by human eyes. What kind of geology do they hold? What minerals? What rock types? What fossils? We do not know. They exist in complete inaccessibility beneath the East Antarctic ice sheet, their peaks touching the underside of more than a kilometer of ice. They are a mystery, and they will remain one for the foreseeable future. There is something unexpectedly wonderful about that. A mountain range the size of the European Alps that remains completely unknown, preserved in ice and darkness, a secret the continent keeps. Antarctica has a particular quality of light during the polar day that photographers who have experienced it describe with near religious intensity. Because the sun is always low on the horizon, never rising high, the light is always golden hour light, that warm, oblique, shadow-stretching quality that photographers chase for a few minutes each morning and evening at other latitudes. In Antarctica in summer, this light lasts for weeks. Everything is bathed in gold and orange and pink. The ice, which is white, becomes a canvas for every color in the light spectrum. The shadows are long and purple. The distant mountains glow amber. The sky is a perpetual soft sunset. The surface of a glacier in Antarctic summer, lit from the side by a sun that barely rises above the horizon, is a landscape of astonishing texture. Every crystal casts its tiny shadow. Every fracture catches the light differently. The uniform white of snow seen in direct overhead light becomes, in oblique light, a complex tapestry of texture and color. The wind, even when it blows gently, shapes the snow into forms that look almost intentional. Sastrugi aligned in the direction of the prevailing wind, like combed hair. Wind scoops in soft hollows, ripples in the snow surface, like sand in a shallow stream. The landscape is continuously being written by the wind, erased, and written again. If you enjoy the channel, and have not yet, please feel free to check out the Sleepy Nature playlist. There are more of these peaceful journeys waiting for you whenever you need them. In some areas of the coast, where ice shelves extend out over the water, the sound of the ice is audible. Ice makes sounds, creaks and groans as it flexes under tidal forces, deep booms as crevasses open or close, hisses as trapped air escapes from below the surface. These are the sounds of something immense and alive, adjusting its enormous weight, breathing in the way that ice breathes. When icebergs calve, the sound carries across the ocean for hundreds of kilometers. A groan, a crack, a deep concussive boom, and then the splash, and then the berg is free, beginning its slow journey north. Some bergs produce low, almost inaudible rumbling sounds, sounds below the threshold of human hearing, infrasound, that carry through the ocean for thousands of kilometers, recorded by distant seismometers as tiny perturbations. Antarctica is constantly speaking in languages just below the range of human hearing. It is communicating with the rest of the ocean, with the atmosphere, with the sea floor. Pressure waves, sound waves, moving through water and air, carrying information about the state of the ice to instruments placed thousands of kilometers away. We have learned to listen to Antarctica in new ways, And what we hear is a continent doing what it has always done, in the same rhythms it has always kept. Let those deep, slow rhythms carry you now, the groan of ancient ice, the hush of diamond dust, the long, low breath of the katabatic wind descending the plateau, the silence between sounds, which is itself a sound in Antarctica, a positive presence, a thickness of quiet that you can almost lean against. Let it hold you. Let it carry you. There is nothing that needs doing in the next 8 hours. Only rest. The Antarctic Treaty, signed in 1959 by 12 nations and now adhered to by more than 50, designates Antarctica as a place dedicated to peace and science. No nation may claim sovereignty there. No military activity is permitted. No nuclear weapons, no nuclear waste disposal. The continent is, in a very real legal sense, a commons, belonging to no one country, held in trust for humanity and for the future. It is the only place on earth where this is so. The treaty's science provision means that all research findings from Antarctica must be shared openly with any signatory nation that requests them. The principle is simple and remarkable. Knowledge gained in this extreme, expensive, difficult place belongs to everyone. The ice cores drilled by Italian and French scientists at Dome C have been analyzed by researchers from dozens of countries. The data from Australian weather stations in Antarctica is freely shared with meteorologists worldwide. This is how science is supposed to work at its best. Open, shared, cumulative. Each discovery builds on the last. Each expedition adds to the record. The Antarctic Treaty, for all the practical pressures on it, has held for more than 60 years, and the science conducted under it has transformed our understanding of the planet we live on. Research stations in Antarctica are small, close communities. In winter, the numbers drop dramatically. Some stations have only a handful of people. The McMurdo Station, the largest, can house up to 1,200 people in summer, but in winter, the population drops to around 200. The smaller stations might have only 10 or 20. In these small communities, relationships are close and roles overlap. The same person might be a scientist, a cook's helper, and a maintenance worker, depending on what the community needs on a given day. People who have spent a winter in Antarctica often describe a deep change in how they experience time. The enforced isolation, the darkness, the limitation of stimulation, the simplicity of daily routine, all of this strips away the noise that normally fills a modern life and leaves something quieter underneath. The simplicity of needing to do only a few things: keep warm, eat, work, rest, is something that many find they miss when they return to the complicated world. The penguins of Antarctica, for their part, appear to have no difficulty with the darkness. Emperor penguins begin their breeding cycle in Antarctic autumn, precisely as winter is beginning. Their timing is essential. The eggs incubate for approximately 65 days, and if the timing is right, the chick will hatch just as the days are lengthening and the sea ice is retreating, giving the growing chick the full summer to develop before the next winter comes. The darkness is not an obstacle. It is the setting in which the beginning of life is arranged. The smell of Antarctica is one of the details that people who have been there mention with particular fondness. The air is so clean that it almost lacks a smell, not the absence of smell exactly, but the presence of just the very base note of ocean and cold, stripped of everything else. Near penguin colonies, the smell becomes more distinctive, the rich, ammonia-laden scent of a colony. But on the ice, far from anything living, the air simply smells of cold, of nothing else, of itself. As the night deepens around you, as your breathing slows and your thoughts begin to soften and blur, hold the idea of that clean air, nothing in it that should not be there, just the bare, cold base of the world's breath. Antarctica breathing out, slowly, from the bottom of the planet, cool and clean and endlessly, endlessly patient. You are warm. You are held. The vast desert rests at the bottom of the world, and the world rests in its orbit, and the universe rests in its incomprehensible dark. And in the middle of all that, you are here, soft and still, at exactly the right temperature, at exactly the right moment, drifting down. The sky above Antarctica in the deepest winter holds light that no other sky quite manages. We have talked about the aurora, about the stars, about the diamond dust in torch beams, but there is something else, the zodiacal light, which is rarely seen from light-polluted places but blazes over Antarctica in the clear polar dark. The zodiacal light is sunlight reflected off the dust in the solar system, the debris of comets and asteroid collisions spread thinly through the plane of the solar system. Seen from a dark place with no moon, it rises as a soft cone of pearly light from the horizon, tapering upward into the sky. It is the glow of the solar system itself, made visible. Over Antarctica, without any interference from light pollution or atmospheric moisture, the zodiacal light is bright enough to cast faint shadows. Imagine lying on the ice in the dark and having a shadow cast by the light of solar system dust. The solar system gently glowing, laying your shadow on the Antarctic ice. It is a thought that puts human scale into a new and quietly vertiginous perspective. The Southern Cross, Crux, is the most famous constellation of the southern hemisphere, circling the south celestial pole, never setting below the Antarctic horizon. It is a small constellation, the smallest of all 88, but bright and distinct. Its four main stars form a cross tilted slightly from vertical, and navigators have used it for centuries to find south. Over Antarctica, it circles overhead like a compass, always present, always steady, the permanent reference point of the southern sky. Near the Southern Cross, two bright stars hang in the sky, Alpha and Beta Centauri, the two brightest stars in the constellation Centaurus. Alpha Centauri is the closest star system to the Sun, just 4.37 light-years away. Looking at it over the Antarctic ice, you are looking at the nearest star. Its light left that star about 4 years ago, and has been traveling through space since then, through the void between stars, to arrive at your eye from 40 trillion kilometers away. That light has come all that way to reach you in the middle of Antarctica, in the dark. If you have been with us on this journey and find the channel restful, please do consider leaving a like and a comment. It helps the channel reach more people who might need a quiet place like this. The Milky Way from Antarctica is not a subtle smear. It is a structure. You can see the dark lanes of dust cutting through the bright regions of star clouds. You can trace the curve of the spiral arm we live in, projected on the dome of the sky. Near the galactic center, the Milky Way brightens and broadens, and even with the naked eye, you can begin to see that it is not flat, but layered, complex, immensely deep. The center of the galaxy, 27,000 light-years away, sends its ancient light down to the Antarctic ice. Cosmic silence and earthly silence, both here at once. The ice resting, the stars burning billions of kilometers away. The ocean around the continent, dark and deep, its surface sometimes still. The wind pausing now and then between its long journeys down the plateau. A seal somewhere on the sea ice, breathing slowly in its sleep. A snow petrel on its cliff, tucked away from the wind, its white feathers settling around it like a small, self-contained snowfall. The world has more quiet in it than we usually notice. The background noise of human activity, of roads and machines and voices, fills the foreground of most days so completely that the deeper quiet behind it goes unheard. But it is there, in the Antarctic, where the human noise is essentially absent. That deeper quiet is all there is, and it is not empty. It is full of the sounds of ice and wind and ocean, full of the light of stars and aurora, full of the patient, slow work of life in one of the most unlikely places on Earth. There is no tension in the Antarctic night. There is nothing to resolve, nothing that requires resolution. The ice will do what ice does. The penguin will stand where the penguin stands. The aurora will move as the aurora moves. You can be a witness to all of this without doing anything at all. Witnessing is enough. Being here is enough. And tonight, being here in your warm bed with the Antarctic desert somewhere at the bottom of the world is enough. The sky is dark. The wind is far away. The stars are doing their slow, ancient work without your help. You have been given this hour, this warmth, this quiet. Receive it. Let it be enough. Close your eyes now, if you have not already, and let the desert breathe for both of you. It is almost time to sleep. But before you go, let us sit for a moment at the edge of the Antarctic night and breathe it in one last time. The ice is there, 4 kilometers deep in places, holding its ancient archive. 800,000 years of climate history, compressed into cylinders of ice that scientists handle with the same care you would give to the most precious thing you own. Each layer a year, each bubble a breath from the past. The past is always there, patient, waiting to be asked. The glaciers are flowing imperceptibly slowly, carrying ice from the cold interior toward the coast, toward the waiting sea. In 100 years, the ice that sits today at the South Pole will have moved a few meters. In 1,000 years, a few tens of meters, in 1,000,000 years, it will have reached the coast and calved away and melted and risen as water vapor over the ocean and fallen as snow somewhere, perhaps back over Antarctica, beginning the cycle again. Water does not stop. It goes on and on, wearing its many forms, vapor, liquid, ice, in a cycle that has been turning since the oceans first formed billions of years ago. The katabatic winds are descending the plateau, low and cold and quiet. Not the fierce gusts of a storm, but the gentle, persistent exhalation of the ice, breathing outward toward the sea. The wind lifts a fine dust of snow crystals and carries them a little way, and the crystals sparkle in the faint starlight, and then they settle again, and the air is still. A Weddell seal somewhere out on the sea ice is sleeping on its side, its round body pressed against the ice, its whiskers twitching in a dream. Emperor penguins are huddled on the winter ice, thousands of them, sharing warmth in the dark. A snow petrel is roosting in a crevice in the cliffs of an exposed rocky outcrop, tucked away from the wind, its white feathers perfect and unruffled, its small body warm inside. On the seafloor, far below, the ancient sponges are doing their slow, continuous work. The krill are moving through the dark water just below the underside of the sea ice. The ice algae are dormant, waiting for spring light. Everything in its time, everything at its pace. Nothing rushed. Thank you so much for spending this time with us. If these stories bring you rest, please do leave a like. It truly means a great deal. And the Sleepy Nature playlist is there for you whenever you need it, full of quiet places just like this one. The Antarctic desert holds within it a teaching, though it offers it without words and without insistence. The teaching is this: abundance is not required for beauty. Warmth is not required for wonder. Busyness is not required for life. The most spare and bare and empty-seeming place on earth is also one of the most extraordinary, most intricate, most alive. It holds more history than anywhere else on earth. It drives the ocean currents that warm the rest of the world. It watches the stars with unfiltered clarity. It makes ice that glows blue, and sky that ripples green, and air that sparkles with diamond dust. You do not have to do anything right now. You do not have to solve anything or plan anything or remember anything. The world will be there in the morning, unchanged and waiting. For now, there is only this: the soft weight of your body in your bed, the warmth that has gathered around you over these hours of quiet, the breath that moves in and out without any effort of your own. Antarctica is resting at the bottom of the world. The stars are burning in their ancient patterns overhead. The ocean is turning in its great, slow circulation, and you are here in your warmth, in your quiet, in your particular small patch of the world, held and safe and drifting. Close your eyes. Let your hands relax. Feel the softness of where you are. There is nothing to hold on to. There is nothing to carry into sleep. The ice breathes. The wind is soft. The desert rests. And so do you.